Class, whenever you see this, this is saying y prime, which is the rate of change of y, that's y prime, and this is saying proportional to y. So this is saying the rate of change of y is proportional to y. If you ever see something that uses that phrase, the rate of change of y is proportional to y, then you run into this formula right here. Because if you integrate this, this formula is derived, comes about. And that's what you need to know, this shortcut, and not have to sit here and integrate this on a test. You don't want to take that time. Now, second of all, this formula is the same as this formula, except this is one we use for money. This is the general formula. You can use it for substances growing and decaying and things like that. And we'll talk about that in other practice problems. So, find the equation in this form that passes through these 2 points. Now, what you need to first understand is this is your time and this is your y value. Now, normally it's x and y, but in this situation, it's t. T is your x. So it's ty and ty. So, in order to find the equation in this form, the first thing I want to do is plug in 0, 4. So if I take my equation, you get 4 equals c e to the k times 0. So I basically, in that equation, I plugged in 0 and 4. And the reason I plugged that number in, what's k times 0 is 0. What's e to the 0? 1. So don't I basically have c is 4? Well, doesn't that make sense that c is 4? Because isn't p or c the initial value? What you should learn is this first number is always your initial value. When time is 0, that's that first number. That number is always when time is 0, initial value. So, what I now have is I now have the equation y equals 4e kt. Now I'm close to having a function. I need to now find k somehow. And then I'll have a function in the proper form we're looking for. And here's how you find k. You simply take this equation, plug it in. So we have 5 is our t, and 1/2 is your y. So this is 1/2 equals 4 e to the k, and t is 5. So can we solve this for k? And then we have our equation. So first thing I'm going to do is divide by 4. So if I divide both sides by 4, I get 1/8 equals e to the 5k. Now, if I want to change this to a log, I'm going to first write it like this. It's easier to look at it this way in order to change it to a log. And the way you change it to a log is it's going to be log base e 1/8 equals 5k. Which is ln 1/8 equals 5k. And we can divide by what? Divide by 5. And that could be k. But there's actually a little bit more simplification you could do. I think the book leaves it like this. Okay? But watch this. I'm going to do a little bit more simplification. What is division in terms of natural logs? Minus. It's a minus. So I'm going to write this as k equals ln 1 minus ln 8. Now, why would I do that? What's ln 1? That's 0. So couldn't I simply make k now negative ln 8 divided by 5, or also ln 8 divided by negative 5? Is that a little bit prettier? Hopefully you can see that ln 8 divided by negative 5 is a little bit prettier. Now, let's now plug this in, and we have our equation. So our equation is simply y equals 4 e to the ln 8 over negative 5 t. And that is our equation. There's our first value, there's our k.